Hello students, all of you welcome to Future Doctor NEET Academy. In our academy we have good facilities and good faculty. If you want to crack your NEET examinations, please come and join. It will be very useful to you. Within 45 days you can crack your examinations. You can use to join MBBS course. So please believe us, we are doing better for you. Okay. So today we have problem solving session for chemistry. I have taken the chapter is thermodynamics. It's also very important topics. We have compulsory 1 or 2 questions they will ask. Okay. So problem oriented topic. So here also we have some formulas will be there. So if you know that formula, you can use to solve the sums. See the first question. In a process, 701 joule of heat is absorbed by a system and 394 joule of work is done by the system. What is the change in internal energy for the process? So this is a question. So internal energy means, the energy present inside the object. That's called, the internal energy. So it has one formula for that. That is represented by, we use the symbol U. Okay. Change in energy, then we use what? Delta U. Delta U is equal to, Q plus W. That's the formula. Okay. So Q nothing but, heat. W nothing but work done. Okay. So here sometimes it will be positive, it will be negative, or this also positive, or this also will be negative. Okay. Suppose whenever heat is absorbed means Q is positive. Heat is evolved means the Q will be negative. At the same time, work is done on the system means W is positive, by the system means negative. Understood? So here now see the sum. 701 joule of heat is absorbed. Heat is absorbed. Heat is absorbed means what? I told you what? Q is positive. Understood? Okay. Q is positive means here, the system absorbs 701 joule. So simply we can put what here? What? 701 positive value. Understood? Suppose the system evolves some heat means we should put what? Minus 701. Understood? So heat is absorbed means Q is positive. And see the next one. 394 joule of work is done by the system. So by the system means, work, no. W is what? W is nothing but here, work done. It is by the system. Then only I'm saying it is what? Work done is what? Negative. Understood? Okay. So work is done on the system means positive. Work is done by the system means negative. Okay. So here, how much work done here? 394 joule of work is done by the system. Then only I put what? Minus 394. That's all. Simple sum. Very easy one. If you subtract, we can get the answer. Understood? So, 700 minus 394 means, I think it will be nearly what? 307 joule. Okay, that's the answer. Understood? 307. Are you following? Okay. So this only you should remember in this type of sum. Heat is absorbed means positive. Heat is evolved means negative. Q. Understood? Work is done on the system means positive. Work is done by the system means negative. Okay. So if you know this, you can use to solve the sum. The formula is delta U is equal to, that Q plus W. Understood? This is a simple formula. Okay. If you remember this one, you can use to solve the sums. Understood? Okay. Now let us see the second question. For a chemical reaction, the values of del H and del S. Del H means enthalpy change. Del S is called entropy change at 300 Kelvin, or the value is given. Del H is minus, that. Okay. Del H is what? Del H is given minus 10 kilojoule is given. Understood? In del S is also given. Del S is what? Minus 20 joule. Okay. Understood? Okay. Then they are asking to find out only delta G. Then the temperature is also given. Temperature is what? 300 Kelvin. Understood? 300 Kelvin. Okay. Right. They are asking to find out only del G. Del G means what? Gibbs free energy change. Okay. So when you combine all these terms, we have one formula for that. What's the formula means? Del G is equal to what? Del H minus T del S. That's the formula. Okay, if you remember this formula, you can use to solve the sum. At the same time, you see the unit also. See the unit del H is what? Kilojoule. This is called joule. Okay. Now see the question all in kilojoule. Understood? So you convert it into what? This is, we can write what? Outright minus 20 into 10 power. Convert to kilojoule, no. So 10 power minus 3. Understood? 10 power minus 3, kilojoule. Joule, no. So we are converted into, this also kilojoule, this also kilojoule. Now only we can able to substitute. Okay. So this is, minus 10 minus, T is what? 300. Okay. Delta S means, into minus 20 into 10 power minus 3. So simple. Okay. Then that minus, so automatically here it will be plus. Okay. 300 into 20, we have 6,000. Okay. Into 10 power minus 3. Understood? That by 1000 it will be what? Minus 10 plus 6 only. Understood? By 1000 means it will be 6 only. So minus 10 plus 6, no. So answer will be what? That minus 4. Understood? Simple one. So A is the option. Understood? A is the correct answer. Are you following? Only one thing you have to remember, both in same quantity or not. One is kilojoule, one is joule, no. So it should be in same. That one you should see. Then you should remember the formula. If you know this, you can use to solve the sums. Understood? Next one, model sums we have. For the formation of ammonia, N2 plus H2 gives NH3, delta H naught, nothing but, I already told you, naught means standard enthalpy of reaction, okay, is minus 92.4 kilojoule per mole. What is the standard enthalpy of formation of NH3 gas? Okay, formation, see, just remember, formation of ammonia means how ammonia is formed. Formation means, just remember, 1 mole only we want only 1 mole, not more than 1 mole. Formation, enthalpy of formation means 1 mole. Okay, 1 mole, how 1 mole of NH3 is formed? See, NH3, this is called 1 mole, no? Okay, how 1 mole is formed? What are the elements are needed to form this? You know that? N nitrogen is needed, no? Nitrogen means always we say what? N2. Hydrogen, it's a diatomic molecule, no? So we should say what? H2. See, I want to prepare 1 mole of ammonia. Okay, ammonia. So here N2 plus H2 gives NH3. So N2 means you put what? Here we have to balance the equation. No, then only you should not touch any. You should not add anything. Okay, you should not add any numbers in front of this. This is a 1 mole of ammonia. For preparing 1 mole of ammonia, we put what? We should take what? Half mole of N2. Are you following? We want to get 1 mole of ammonia. We should take what? Half mole of N2 and what? Here 3 hydrogen is present. No, 3 hydrogen means we should put what? 3 by 2. You just multiply 3 by 2 into 2. 2 to cancel. We have 3 hydrogen. No. Okay. So half mole of nitrogen and 1.5 mole of hydrogen to get what? 1 mole of ammonia. Okay. So this is a way to find out. Understood? So formation means we want to prepare only 1 mole of ammonia. Okay, that's a question. Okay. So what the symbol means here? You know that what's the symbol? Enthalpy, standard enthalpy of formation. The symbol is what? Delta H. Standard means not. Delta H of formation, F is equal to question mark. Okay. Standard enthalpy of formation. Okay, this one we have to find out. Okay. But what they given? The given is what? Standard enthalpy of reaction. Reaction means here we don't have any fraction all will come. Here, suppose, right, to put the same equation here. See, N2 plus 3H2 gives what? 2NH3. That value is given. This is called nothing but standard enthalpy of reaction. R means, R stands for reaction. F stands for formation. Understood? Okay. So this is given. This value is given. Okay. So minus 92.4 minus 92.4 value is given. Okay. See, now we have to find out only 1 mole. Here, see, listen. 2 mole of ammonia is formed. This much energy is required. Therefore, 1 mole is formed how much? You just compare like that. Okay. If you want to get 2 mole of ammonia, this much energy is needed. This much of energy is evolved. Okay. Whenever del H is negative means always it's exothermic reaction. You know that. Okay. Understood? Are you following? Whenever del H is negative means what? It's called what? Negative means exothermic reaction. Whenever del H is positive means what? Positive means what? It is a endothermic reaction. Understood? It's a basic one. You must know. Okay. See, you just compare. For 2 mole of ammonia, this much energy is needed. Therefore, for 1 mole of ammonia, they are asking only formation. No, formation. Okay, formation. So 1 mole of ammonia, how much energy is evolved means you just half of this. Okay, you know what's half of this? Okay, so half of this means what? You know, nearly 46.2 minus 46.2. Are you following this answer? Are you following? 2 mole of ammonia, this much energy is evolved. But formation means always 1 mole. Just remember. Okay, 1 mole. Okay. So 1 mole of ammonia, how much energy is evolved? So half of this value is nothing but B is option. Understood? Okay. Are you following? Simple one. Next question. See, 2 chlorine atom becomes chlorine. This is chlorine atom. 2 chlorine atom becomes chlorine molecule. Okay. That time, what's the del H value? What's the del S value for this reaction they are asking? Okay, understood. So you just remember, usually, del H and usually del H and del S. What is del H? What is del H? Del H means enthalpy of the reaction, you know. Okay, or heat changes at constant pressure is called what? Enthalpy, you know. Okay, enthalpy change means, suppose, during exothermic reaction, what? During exothermic reaction, this is what? This value is what? Negative. Okay. During endothermic reaction, its value is what? Positive. This only just remember. Okay. Understood? Then, see here, you know, chlorine atom becomes chlorine molecule. No. Okay. So chlorine atom becomes molecule means one bond is formed. One bond is formed, then only it becomes molecule. Whenever the bond is formed means at the time, you know, whenever the bond breaks, you know, generally, you know, whenever here is the, you know, it's a bond between A and B. Okay. Whenever if you want to break the bond means we must give energy. Then only we can able to break the bond. If you give energy means what? That kind of reaction is called what? Endothermic reaction. So endothermic reactions, I already told you, del H is always for positive. Here, whenever atom becomes molecule, the bond is formed. During bond is formed, del H is value is what? Always negative. Okay. So del H is negative. Understood? Are you following? During bond formation, always del H is value is what? Always negative. Okay. Now come to del S. Del S nothing but entropy change. Entropy. You know what is entropy? Disorder of the, simply we can say disorder of the molecules. Whenever the molecule disorder, you know that, suppose I'm taking solid, liquid, gases. Okay. Whenever the states comes from solid, liquid, gases, in solid state, the molecules are orderly arranged. You know that. Whenever the molecules are orderly arranged means entropy is 0. No disorder taking place here. When come to liquid state, there is some disorder. When come to gaseous state, it is more disorder. Whenever more disorder, wherever the more disorder taking place, that states only entropy will be very high. In gaseous state only, the entropy is more. Okay, entropy nothing but disorder. Okay, disorder is called, we can say, entropy. Understood? Okay. Here, no. In this case, number of, you see the left hand side here, 2 species are there. 2 species are there. No, 2. Right hand side we have only 1 species. Whenever the number of species decreases, entropy is also what? Decreases. Understood? Here entropy is will be, see, left hand side, two particles becomes one particle. Okay, 2 atoms becomes one molecule. When the number of particles decreases from left to right, this also what? Del S is also what? Del S nothing but entropy change. This also decreases. Understood? Are you following? Del S is negative. When it is negative, number of moles of product is less than number of moles of reactant. So in this case, again it will be decreases. So here atom becomes molecules, isn't it? Then only del H is negative. So here the bond is formed. Whenever bond is formed, del H value is negative. Understood? Here I told you, here 2 particles are there, here 1 particles are there. So number of particles decreases means del S is also decreases. It will be less than 0. Okay, these 2 only remember. Okay, suppose here more particle, here less particle means increases. Okay. So product side, I told you clearly, number of moles of product is less than number of moles of reactant means del S is always negative. Okay, this only just remember. Then only I am saying del S is also what? Del S is also less than 0. Then only I put what? Del S is what? Negative. Okay. I given only one, but you remember, if it is NP is greater than N of R, number of moles of product is greater than number of moles of reactant means you just imagine, you can write yourself, it will be positive. But in this reaction, it will be negative. So both are minus, no. Then only I put A is the correct option. Understood? Okay. Now see the next one. This is also one formula based, some very simple one. Molar heat of vaporization of a liquid is 4.8 kilojoule per mole. If the entropy change is 16 joule per mole per Kelvin, the boiling point of the liquid. Okay, so that's a formula. Here there's a relation between entropy change and molar heat of vaporization. What's the relation means? You know, del S is what? Del S is del H of vaporization. Okay, enthalpy of vaporization by temperature in Kelvin. Okay, temperature in Kelvin. Okay, that's a formula. Simply you can substitute. Okay, so before substitute, you must remember. So this is in joule. This is in kilojoule. This only you should remember. Okay. Okay. Now, okay. So this only you have to remember. Now you substitute. Molar heat of vaporization is what? You know, molar heat of vaporization. Molar heat of vaporization is what? You know what? 4.8. Okay, by convert into joule. No, this is kilojoule. So you convert into, you know, kilojoule means what? The kilojoule convert into joule into 10 power minus 3. Understood? Joule per mole per Kelvin. You know, temperature is, you know, temperature only they're asking. The boiling point of the liquid. They're asking, we have to find only the temperature. No, del S is what? 16. Understood? Okay. Now interchange. That's all. You following? Now, therefore what? You know that, therefore, T is equal to what? 4.8 into 10 power minus 3 by, you know, 16. Understood? Okay. Understood? Okay. See the unit 4.8, no? 4.8 kilojoule, no? This is only joule. Okay. Okay. So here, the bigger unit into smaller unit, no? Bigger unit. So here we have to multiply by what? 4.8 kilojoule per mole. Here entropy change is 16 joule per mole. Okay. The unit only we have to check correctly, then only we can get the answers correctly. Understood? Now, see 4.8 in 10 power minus 3 by 16. Okay. So this will be, sir, this is kilo, this is joule, no? Okay. But this is what? Okay. This is what? Automatically what? This is positive term. 10 power 3. Understood? It's a, if you put, instead of K, we put 10 power 3. Okay, now it comes correctly. See that this will be positive, no? Into 10 power 3. Understood? Okay, now you can multiply. Suppose here, you know, 4.8, I take 110. So it will be what? 48 by 16 into 10 power 2. Okay, now, you know, if you cancel means what? What happened? If you cancel means it will be this is 1 time, this is 3 times. 3 into 10 power 2, answer is what? Answer is 300. Okay, understood? So Kelvin. So this answer. The following answer A is the correct one. Understood? So when but the formula oriented sum, you just check the unit. This is in kilo, the joule, this is in joule. So if you put correctly, then only we can get the answer. The following? Okay. So the formula is del S is equal to del H by T. Simply we can say it may be vaporization or sublimation. Okay. Or fusion. Okay. So anything it will be there. Okay. So anyway, the formula will be del S is equal to del H by T. Understood? The following? Okay. Now see the next one. An ideal gas expands in volume from 1 into 10 power minus 3 meter cube to 1 into 10 power minus 2 meter cube at 300 Kelvin against pressure 1 into 10 power 5 Newton per meter square. Work done is they're asking. Okay, work done. So here also formula we have. Generally we know when the pressure increases, volume will be decreases. Okay, that concept based on. Okay, so here work done formula is what? W is equal to what? Minus P into delta V. This is the formula. Okay. Delta V nothing but change in volume. Okay. So we are how much pressure we are giving means, the pressure is given at constant, this much pressure. Okay. This is 1 into 10 power 5. No. I simply write minus 10 power 5. Okay. Then this is nothing but change in volume. Change in volume from V2 to V1. Volume. Okay. Final volume minus initial volume. So volume from final volume is what? It's a final volume. Okay. Final volume minus initial volume. Simply I put what? 10 power 5. Understood? Minus 10 power 5. Just substitute. This is a simple one. Final volume is 1 into I simply consider as 10. I leave it 1. That is 10 power minus 2 minus volume. 1 is what? Initial volume is what? 10 power minus 3. Understood? Okay. Then how to simplify? If we simplify means we get the answer. Okay. This is, how to simplify. This is, you keep as it is 10 power minus 5. Okay. This is, 1 by 100. No. 1 by 100 means, this is considered 1 by 100. 1 by 100 means what? 0.01. This is 1 by 1000. No. So I considered 0.001. Are you following? Water method. Water method, if you know, you can able to solve simply. Okay. I follow one method. Okay. You follow my method. Then you subtract 0.0901 minus 0.009 means what? So we get the answer here. I write it here. This is minus 10 power 5. Okay. So if you subtract means what's the answer? We will be getting, when you subtract means we will be getting what? 0.009 we will be getting. Understood? Okay. Okay. Then again 10 power 5. Understood? Okay. Then this outright 9 into 10 power. Can you able to write like this? Okay. Then 10 power 5, 10 power minus, it will be, when you compare these two, what? It will be what? Minus, 9 into 10 power 2. Okay, so now we get the answer, 900. Understood? So among this, A is the correct option. Are you following? Understood? Okay. Just remember the formula. If you know the formula, we can use to solve the sum very easily. This is the formula. Work done is equal to minus pressure into delta V. Okay, delta V nothing but change in volume. I put it V2 minus V1. Understood? Okay. Now go to the next one. Last problem in this lesson. See, the dissociation energy of methane and ethane are, methane value is given. Okay. Ethane value is given. Understood? The value of bond dissociation energy of CC bond. So if you want to break CC bond, how much energy is required? They are asking. Okay. Simply see. First, you know the formula for methane. Simply, what's the formula for methane? Methane formula is what? It's a methane is a tetrahedral molecule. sp3 hybridization. This is all you know. Okay, understood? Okay, it's a here 4 CH bond. No, the bond dissociation energy of methane is given. What is the value is given? 360. In methane, how many CH bond? There are 4 CH bond. Understood? In methane, we have 4 CH bond. So 4 CH bond. 4 CH bond. If you want to break 4 CH bond, the energy is what? Is given. This is given. What's the value? 360. Are you following? If you want the bond is energy of methane, nothing but if you want to break in methane, we have 4 CH bond. 4 CH bond, if you want to break means this much energy is needed. Therefore 1 CH bond, if you want to break means how much energy is needed? How much energy is needed? Simply 360 by 4 means what? That is a 90. Are you following? In methane, we have 3 CH bond. If you want to break all the, in methane, we have 4 CH bond. If you want to break the bond, this much energy is needed. So, therefore, the energy required to break 1 CH bond is 90. Understood? Okay. Then come to the ethane. In ethane, what's the formula? C2H6. Understood? How to write C2H6? C. Understood? H. It's a formula for, it's a structural formula for, ethane. Understood? You know that? Structural formula for ethane. Okay. Ethane energy is given. What is ethane energy value? 620. Understood? See, in ethane, how many CH bond? 1, 2, 3, 4, 5, 6. So 6 CH bond. 6 CH bond plus what? 1 CC bond. Are you following? 1 CC bond. 1 CC bond. CC bond. 1 CC bond. Understood? So all the energy, all the bond, if you want to break means how much energy is needed? We need 620. We need 620 kilojoule. Kilocalories per mole is given. Okay. We know 1 CH bond. What is 1 CH bond? We just now we found out. No, 1 CH bond just now we found out. What is that? 90. So 6 into 90. Okay, plus CC bond. What's the question? They are asking to find out only bond dissociation energy of CC bond. This one we have to find out. Okay, simple one. 620. Are you following? Therefore, 6 into 90, 540. Okay, understood. Therefore, CC, if you want to break 1 CC bond, 620, just understood, that is 620 minus, just, this is what? 6 into 90, 540. Understood? Okay, right. Then if what's the answer? 620 minus 540, that 80. That's the answer. Answer is what? You subtract, we get the answer what? 80. Okay, now see the option. C is the correct one. Are you following? Okay. So 1 CH bond, if means we can find out other that value we are substituting here, then we can find out for ethane also we can find out. Okay. CC bond also we can find out. Okay, understood. This is very, very important. Okay, suppose here telling in ethane, this statement is very, very important. Okay, if you want to break all the bond in ethane, value is what? 620. Okay, in ethane, we have CH bond is present. At the same time, we have CC bond is also present. CH bond we are finding from there. Then only we can able to find out the CC bond. Okay, in ethane, we have 1 CC bond. But in methane, no CC bond. No, only 1 carbon. No. Okay. So if you know this type of sums is very important. Okay, sometimes I put only ethane, sometimes they will ask to find only propane. Propane means the formula, no, C3H8. Understood? I hope you understood everything. Okay, any doubt means you can ask in the comment section. Okay, thank you, students.